Hello everyone, in this video we will be proving the product rule for derivatives. So you have differentiation of the product of two functions f and g, they both are functions of x, is equal to f times the derivative of g plus g times the derivative of f. So you are treating f as constant, then differentiating g, and then treating g as a constant and then differentiating your f function. Now the usual proof is then using the standard definition of a limit and then adding and subtracting something, but that's not what we are going to do here. We are going to follow a geometric approach. Okay, so first let's start with the definition of a derivative. That's a standard thing to do. So f times g will be the limit as delta x tends to 0, f of x plus delta x times g of x plus delta x minus f of x times g of x divided by delta x. Now let us understand what this means geometrically. Now f of x represents side this length. Okay, this is your f of x, and g of x as this length, and f of x times g of x as the area of this rectangle. Okay, this is your f of x and this is your g of x, and that is what happens. See, whenever you have, let's say, f versus x, you have some graph. So at some point x you will have some value, okay, g and x, so you have something like this, and at some x you have some value, and if you are multiplying f and g, you are multiplying these two lengths. If you multiply these two lengths, you get the area of a rectangle. So that's how we are representing f of x times g of x as this area. Now we need to evaluate this quantity, f of x plus delta x times g of x plus delta x. So this will be another rectangle, okay, having a bigger size. So this is what it will look like. So you have g of x, and you extend this, so this total length will be g of x plus delta x. Okay, and similarly you extend your f of x by some amount, and this will be f of x plus delta x. Okay, and then you complete this rectangle. So this, the area of this bigger rectangle, okay, this rectangle having the green edge will be f of x plus delta x into g of x plus delta x, and to evaluate the numerator we need to find this term minus this term. So the area of the bigger rectangle minus the area of f times g, this smaller rectangle. So I left with this area, the area having the green side as the edge. So we need to evaluate this area. Just divide this into parts, okay, and then sum up the areas of the individual rectangles. Now if this length is g of x plus delta x, this length is g of x, this means this length will be g of x plus delta x, bigger length minus the smaller length g of x. Okay, this length will be equal to this length, this one will be equal to this one, this will be again f of x, okay, till this point, and this length will also be this one, g of x plus delta x minus g of x. Similarly, this length will be f of x plus delta x minus f of x, and this length will be g of x. So you have areas 1, 2 and 3. So area 1 will be equal to f of x times this length times this length. This length is the g of x plus delta x minus g of x. So I'm just writing this down, plus this area, it will be g of x times f of x plus delta x minus f of x, plus this area. So this length is this, and this length is the same as this length. The area will be the product of these two. So plus, this is a long term, f of x plus delta x minus f of x times g of x plus delta x minus g of x. So this is your numerator, the area having the green edge, and this quantity divided by delta x, and then we take the limit as delta x approaches 0, will give us the derivative of your f times g. So let me write this down in a different form. So you have limit delta x approaches 0, f of x g of x plus delta x minus g of x divided by delta x, plus limit as delta x goes to 0. So we have broken up the limits. Okay, g of x times f of x plus delta x minus f of x divided by delta x, plus this product, limit delta x goes to 0, this stuff, f of x plus delta x minus f of x into g of x plus delta x minus g of x is delta upon delta x. Now we need to evaluate this term. So in this term, your f of x will go outside the limit. See, when you evaluate, when you are evaluating this thing, okay, at your x will be fixed. So your f of x will have a fixed length. It is your delta x, this thing, that you will be changing. Okay, so we really need to evaluate this limit. While treating your f of x as constant. So you just pull this out and you're left with limit delta x approaches 0, this term g of x plus delta x minus g of x upon delta x, and this is your definition of a derivative. This will be your derivative of g with respect to x. Similarly, you can pull g out of this limit. You have g of x times df by dx, plus now we need to evaluate this limit. Now for this you can you should combine delta x with one of those terms, either combine it with this terms involving f or terms involving g. You will get the same result. So I am combining this with f when delta x approaches 0, f of x plus delta x minus f of x divided by delta x times the limit delta x approaches 0, g of x plus delta x minus g of x. This term is again your derivative of f with respect to x, and this term limit delta x approaches 0, g of x plus delta x minus g of x will be 0, because when you will put delta x as 0, you will get g of x minus g of x, which will be 0, and you can visually see. So if you are plotting g with respect to x, this is your g of x, and this is your g of x plus delta x. This is g of x plus delta x. This will be g of x. This length will be delta x. So as your delta x will reduce to 0, this point will gradually move towards this point. So when it will be equal to 0, this point will be on this point, and your function will decrease to your g of x. So you will get g of x minus g of x, which will be 0. So this term is 0. This entire quantity, this limit times this limit, will be equal to 0. So all of this will be equal to 0. So left with this term, which is simply f times dg by dx plus g df by dx, which is the product rule as we have proved. This is what we have stated. Now, using this product rule, you can also derive the quotient rule. Let's see what happens. So this is what we have proved, and we need to find the derivative d by dx of f upon g. So we have one numerator and a denominator. Now this is quite trivial. You just have to replace g with 1 upon g. So f by g is just f into 1 by g, and then you can use the product rule. So we have f times d of 1 by g with respect to x dx, plus just replace g with 1 by g. We have 1 by g d f by dx. Now to evaluate 1 by g with respect to x, we will use the chain rule. So we will differentiate 1 by g with respect to g, and then we will differentiate g with respect to x. We have f 1 by g is g to the power minus 1, okay, d minus 1 with respect to g, and then differentiate g with respect to x plus 1 by g df by dx. Now using the power rule, we get minus 1, g to the power minus 1, and then minus 1, we subtract 1 from the exponent, g to the power minus 2 times dg by dx plus 1 by g df by dx. Okay, you can write it again like this: minus 1 upon g square times f times dg by dx. Now you have g square, so we want to make g square in the denominator in the first term. So we multiply and divide by g. Now we can bring g out, g square out. G square will have g df by dx minus f dg by dx. You can write it in another form, okay, much more convenient notation. Your denominator times the derivative of your numerator minus the numerator times the derivative of your denominator, and divided by your denominator square, and this is your quotient rule. So differentiation of some function in the numerator divided upon some function in the denominator is your denominator times derivative of numerator minus numerator times derivative of denominator divided by your denominator square. So that's it for today's video. I hope you learned something new and enjoyed watching. Thanks.